Rightio, hello students. Today we're going to look at the volume of prisms and cylinders. So the learning goal for the day is to calculate the volume and capacities of standard three-dimensional objects, including rectangular prisms, cylinders, and composites in practical situations, such as the volume contained in a swimming pool. So today we are working in, what do we say? 3 dimensions, and we are looking therefore at volume and capacity. So the units we'll be using are cubic units. So 3 dimensions. So we have meters times meters times meters. So a meter cubed, for example. And capacity is what we're quite used to, for example, if we pour milk out of its container. We'll come back to that one later. So the point of today's lesson, we're going to look at the volume of prisms, and we'll also look at some volume conversions with capacity. Okay, when we are working with cubic units, we are now multiplying each conversion factor by 3. So you remember that there's 10 millimeters to 1 centimeters, but in a cubic millimeter, or a cubic centimeter I should say, we have 10 by 10 by 10, or 1,000 cubic millimeters. So if we want to convert 30 cubic centimeters into millimeters, what do we need to do? We need to think, well, millimeters is the smaller unit, and centimeters is the bigger unit. So smaller unit, bigger number. So we're going to just go 30 centimeters cubed times 1,000 will give us 30,000 cubic millimeters for 30 cubic centimeters. Now if we want to convert cubic kilometers into cubic centimeters, we're going to have a pretty huge number. So where are we? Cubic kilometers, I haven't even put it on here. So if I'm thinking kilometers, what is it? It's 1,000 meters to a kilometer. So it's got to be 1,000 times 1,000 times 1,000. So 1,000 million billion. So there are a billion cubic meters into a cubic kilometer. So we just multiply 4.5 kilometers cubed by what did we say? 1,000 million billion by a billion. And then we want to go the next conversion factor. So by another million, we have a huge number. So it's got 1,000 million billion trillion quadrillion. So 4.5 quadrillion. It's a good reason just to go back to scientific notation, and we can go 4.5 in this case, 3, 6, 9, 12, 15. So we just say 4.5 times 10 to, oh, that's a 15, I should say, 15 cubic centimeters. So that would be the easier way to write that, and just ignore a lot of the zeros then. Now finally, if we want to go from 456 cubic centimeters into cubic meters, well, we think, well, this is a bigger unit, so this has got to be a smaller number. The conversion factor here is 1,000,000. From going centimeters to meters, we have this million conversion factor, so we just divide 456 by 1,000,000, and it's 0.000456 cubic meters. Now the important concept when considering the volume of a prism is that the volume of the prism is the area of the base times the height. Now the base is whatever the cross section is, the constant cross section is. So if we have a look at a cylinder, you can see that it's round, but it's the circle at the top and the circle at the bottom. So that is what is constant. Now a lot of people will tell me that this is a pyramid, but in fact this is a triangular prism. A pyramid comes to a point, and the prism has a constant cross section. So you can see here this triangular prism is constantly a triangle from the base to the top, even though it's flipped on its side. So we say the base is whatever is constant. To work out the area of a triangle, remember it's just half the base times the height, and then you just have to multiply with the big H in this case, the other height of the prism, to get the volume. So we can see that we've got 2 heights here. Don't get confused with that. So we've got a little h for the height of the triangle, and then we've got a big H denoting the height of the triangular prism. Now a rectangular prism is just going to be the area of the base. So in this case we've got two constant cross sections. You can choose whatever. In this case we'll use a rectangle, so the length times the width, so the one down the bottom, and then times the height, and you'll get that volume. Now a cube is a three-dimensional figure with all the sides that are the same. So you just need to say side times side times side, or side cubed in this case. So let's have a look at a calculation. So you can see straight away we're going into what we call a composite figure, or a compound figure. So what's the volume of concrete required to make a 2.44 meter long cylindrical pipe that has an outer diameter of 1 meter and a wall thickness of 10 centimeters? So first of all, you're going to have to translate into a diagram. Be noting that we've got different units, so you need to, on your diagram, put it all in a constant unit. Now your plan could be a big cylinder, take a small cylinder. So we just measure the outer diameter, the outer one, and do that, and take away from the smaller one, which is the empty space. And the area times the base times the height is the volume of a prism, and we just need to know that the area of a circle is pi r squared. So when we draw a diagram, we're going to try and translate that, and you can see here that it's 2.44 meters long, it's a meter high. The inner cylinder has a height of 0.8 meters, because that's 0.1 of a meter there, and that's 0.1 of a meter there. So that means we're left with 0.8. So when we solve this, let's just work out the big cylinder volume. So it's pi r squared for the area of the base times the height, which is 2.44. So we'll substitute in pi times 0.5. Where did we get that 0.5 from? That's the radius. So remember, the radius is half the diameter. So from the center point to there, so that should be 0.5. So let's go through that again. So pi r squared, so pi times 0.5 squared times 2.44, and that should leave us with 1.916 cubic meters. Now let's do the small cylinder volume. Same thing, but it's just a smaller radius. So remember, we've got 0.8 down here. Half of that diameter will give us a radius of 0.4. So it's just pi times 0.4 squared times 2.44 will give us 1.226 cubic meters. So that will give us a total volume rounded to 3 decimal places here of 0.689 cubic meters. Now when we evaluate and verify this model, we could say we could do this a lot more efficiently if we had all these numbers left in our calculator. So you could type this into your calculator and round off and just ensure that this number would be more accurate. An alternative solution would be to find the area of the annulus first, or that donut shape. So an annulus we get from the word annual, or sun. So that's just the ring around the sun, or in this case it's a ring shape, and we just find the area of that ring. So big circle takes small circle and then multiplied by the height. And finally, when we communicate, the volume of the concrete is 0.689 cubic meters. Now when we think about volume and capacity, capacity is measured in milliliters, and if I want to think about a litre, then 1 litre is a cube that has a side of 10 centimeters. So if I think about this, we've got a height, depth and width of 10 centimeters. So it's 10 centimeters by 10 centimeters by 10 centimeters. So 10 times 10 times 10 is 1,000. Centimeter times centimeter times centimeter are cubic centimeters. Therefore, we can also note that 1 litre equals 1,000 cubic centimeters. We also know that 1 litre contains 1,000 milliliters. So let's think about the milliliter. A milliliter is a cube that has a side of 1 centimeter. So in this case, it's 1 times 1 times 1. So 1 cubic centimetre is 1 milliliter. So it takes 1,000 cubic centimetres to make up 1 litre. If I want to think about the megaliter, now a megaliter is 1,000,000 litres. So that's quite big. So we've got 10 metres by 10 metres by 10 metres. One side must be the cube root of 1,000,000 lots of 10 centimetres. So in this case, it's 100 times 10 centimetres to be 10 metres for each of the sides. The final one I should point out is the kiloliter. A kiloliter is the same as saying 1 cubic metre, and that weighs about a tonne. Now, when we made the reference system for the metric several hundred years ago, so I was not involved, the metric system was based off water, and so if we think about 1 mil, it has a volume of 1 cubic centimetre, and it should weigh about a gram of water at sea level. If we have a look at 1 litre, it's 1,000 cubic centimetres. It should weigh a kilogram. 1 kilolitre, as I said, is a cubic metre, and it weighs about a tonne. This has changed a little bit recently to be more accurate, because the concentration of water and the temperature will affect this to a very small amount, so there have to be more precise measurements used. So capacity of an object is the internal volume. It's measured in litres, millilitres, and so on. Volume is the space an object occupies. So finally, my swimming pool is 10 metres long and 4.2 metres wide. At the deep end, it's 2 metres deep, and at the shallow end, it's 1.5 metres deep. So let's calculate the capacity of my pool in kilolitres. So my job is to translate this into a diagram. I need to remember that the volume of the prism is the area of the base times the height. In this case, the base is the trapezium, and convert cubic meters into kiloliters at the end. So if I think about my pool, the constant cross-section is that trapezium. So remember we said we've got 2 meters at the deep end, 1.5 at the shallow, 4.2 meters wide, 10 meters long. So when we solve this, we need to think, okay, what's the area of this trapezium here? And then we multiply it by the height. So the area of the trapezium is what? 1.5 plus 2 divided by 2. Then we multiply that by 10 meters long to get 17.5 meters squared. To get the volume, we need to multiply that by the 4.2 here, or here, and that will give us 73.5 cubic meters. Now, 1 cubic meter is the same as saying 1 kiloliter, so the capacity of the pool is 73.5 kiloliters. If I want to think about some real life situations, I probably won't fill it all the way up, of course, because then it might overflow, or the filter or the skimmer box might not work. And finally, we can communicate that the pool's capacity is 73.5 kiloliters.